Good day everyone and welcome to today's webinar on NetSim-SUMO core simulation for VANETs. My name is Kanagaraj Krishnamurthy and I am a senior application engineer at NetSim. Along with me is my colleague Pranav Vishwanathan. This webinar will be about 45 minutes long. In this webinar, we will start with an introduction to VANETs. Next, we will look at an open source tool called SUMO, which stands for Simulation of Urban Mobility. Within SUMO, we will look at 4 basic tasks: creating vehicular network scenarios in SUMO, creating an urban traffic network using NETEDIT, creating an urban traffic network by importing OSM maps, adding vehicles to traffic network in SUMO. After this, we will see how to interface SUMO with NetSim. Subsequently, we will look at VANET simulations with NetSim-SUMO offline coupling. Following this, we will be showing NetSim-SUMO online coupling, covering both one-way online coupling and two-way online coupling. In two-way online coupling, we will discuss an example VANET R&D project involving SUMO's Traffic Control Interface or TRACI. Finally, we will share some R&D areas where NetSim is used and have a Q&A session to answer your queries. We have muted all the participants currently. Please feel free to send us your questions via the chat option and we'll answer them if possible during the session or else at the end. VANET, which stands for Vehicular Ad Hoc Network, is similar to MANETs as it is a spontaneous creation of wireless network of mobile devices applied to the domain of vehicles. VANETs are a key part of the Intelligent Transportation System (ITS) framework. Sometimes VANETs are referred as Intelligent Transportation Networks. The major components of a VANET include onboard units (OBUs), which are vehicles fitted with radio interface, and radio units or RSUs, which are typically installed along the roadside or in specific positions such as near intersections and parking lots. RSUs are required because even though the in-vehicle sensors can access the immediate environment, some information still needs to be communicated from external sources. Vehicle-to-vehicle and vehicle-to-infrastructure applications include information and warning functions for dissemination of road information to vehicles far away from the place problem occurred, such as road incidents, traffic congestion, surface condition, etc. Communication-based control to provide platooning capabilities to improve traffic efficiency and warnings about road accidents ahead. Cooperative assistance systems for cooperation between vehicles such as adaptive cruise control, automatic collision warnings, collaboration at intersections, etc. VANET can be categorized by factors such as vehicular mobility and numerous directional changes, due to which the network topology in VANETs keep varying. Frequent exchange of information. The ad hoc nature of VANET motivates the nodes to gather information from the other vehicles and roadside units. Delay sensitive, since critical information is exchanged about safety, and the RF environment varies widely due to the differences between driving within a city and driving on a highway. Simulators present a valuable tool for testing VANETs at low cost and without risk to users. As performance tests of real systems are very expensive and not comprehensive, Today's evaluations are based on analysis and simulation via simulators. In order to investigate the impact of traffic information systems, network simulators must be coupled with traffic simulators. A network simulator is required because wireless communication characteristics influence the data transfer significantly. A traffic simulator is required to ensure that the mobility model that closely reflects the real behavior of vehicles in traffic. This way, conclusions drawn from simulation experiments will carry through to real deployments. Typically, open source simulators like SUMO handles the road traffic simulation, which includes the effects of lanes, intersections, signals, etc. NetSim captures the complexities of wireless channels and protocols in VANETs. Post-simulation, NetSim outputs network performance metrics such as throughput, delay, etc. SUMO stands for Simulation of Urban Mobility. It is a free and open source traffic simulation suite. SUMO allows modeling of intermodal traffic systems including road, vehicles, public transport and pedestrians. Included with SUMO is a wealth of supporting tools which handle tasks such as route finding, visualization, network import, and emission calculation. SUMO can be enhanced with custom models and provides various APIs to remotely control the simulation. SUMO models individual vehicles and their interactions using models for car following, lane changing, and intersection behavior. It allows creating road networks using network formats such as OpenStreetMaps. It provides Tracia APIs to control the behavior of simulation objects in runtime. No additional effort is required to interface NetSim with SUMO. NetSim installer is bundled with SUMO, which gets locally installed along with NetSim. A SUMO network configuration broadly consists of a network file which defines the road network conditions and a vehicle or routes file which defines the number of vehicles or trips in the simulation, and a configuration file which contains references to the other two files and other parameters associated with the simulation. NetSim can take a SUMO configuration as input and instantiate a network stack for each vehicle. It then simulates the wireless RF propagation and the underlying communication protocols, thereby facilitating VANET simulations. We will now look at how to create a road traffic configuration for SUMO, which can then be utilized for VANET simulations in NetSim. Let us start with creating a network for SUMO. NetEdit is an inbuilt tool that is part of SUMO install directory, which can be used to create a SUMO network file with ease. We will now look at a short demonstration of using NetEdit. NetEdit is available in SUMO install directory in the bin folder. The NetEdit executable can be used to launch the NetEdit GUI, where you can create a new network. We select edges and enable two-way and grid options. Two-way helps creating roads with two lanes. Just click at any location in the grid to drop a node, and another click will create another node and automatically form an edge connecting the two. This is nothing but the road with two lanes. As you can see, in SUMO, we are quickly constructing a road network with each road having two lanes. We then connect edges of existing roads to form even more roads, at the intersection lanes with junctions are auto-created. We also add a traffic signal at the junction. With this, we complete creating a network. We then save it as a network file. This file normally has the extension .net.xml. We save this in our desktop in a new folder called SUMO with the name network.net.xml. Once this is done, we have our network file ready and we can open this in SUMO. SUMO GUI can be launched using the SUMO executable present in the same location as the NetEdit. We browse and select the saved file to see the road network with junctions and traffic signals. SUMO networks file can also be created quickly by importing specific regions from the OpenStreetMaps to make simulations more realistic. This can be achieved in different ways. Using the browser, using the OSM Web Wizard utility that is part of SUMO install directory, using the Java OpenStreetMaps editor, and also using the OpenStreetMap APIs. Specific areas of the OpenStreetMaps can be downloaded as an OSM file from OpenStreetMap website. Downloaded map can be converted into an equivalent SUMO road network using netconvert utility that is part of SUMO install directory. We will now look at a short demonstration of using any web browser to download from OpenStreetMaps and create a network file. We use the Chrome browser and go to openstreetmap.org. Here, we can zoom into any specific region in the map. As an example, we zoom into Bangalore and select the region from where we are broadcasting this webinar. Once we have selected the area, we click on Export to download the OSM map. We now have a map as .osm file which can be used to create our SUMO road network. We create a new folder called SUMO OSM Maps and move the downloaded map.osm file there. We then pass the map.osm file as input to netconvert utility of SUMO via the command line. The output will be a network file which can be directly loaded in SUMO. Once the command is successful, we obtain our network file. We will now attempt to open this file in SUMO GUI like we did previously. We open SUMO GUI and open the network file that we created using the netconvert utility. This is an equivalent of the map that we downloaded from OSM, OpenStreetMap. You can see the roads, lanes, junctions, signals, etc. auto-imported as per the information available in the OpenStreetMap. Before running simulations, vehicular demand needs to be generated for the created network. Adding vehicles to the created network can be done using various options that are available. This includes the random trips utility, which is part of SUMO install directory, VANET demand importers, activity generators, DF router, JTR router, and OD2 trips. The random trips utility, which is a Python script that is available with SUMO, can be used to generate a vehicle or route file for simulation. Once this is done, a SUMO configuration file, which includes references to the network and route file, can be created. The SUMO configuration file also includes additional parameters such as the simulation start and end time, simulation step length, and references to additional settings files, etc. Let us have a quick look at using random trips, loading and running the network configuration in SUMO. In this example, we are using the simple network that we previously created using NetEDIT and not the one we created using OpenStreetMaps. Random trips Python script is available in the tools directory of SUMO. To this, we pass the network file that we created as input. Random trips then generates a route file as output. We are also specifying the number of trips or vehicles as 10. Here, the argument E refers to number of trips or vehicles. SUMO requires the road network and the vehicle trips files. Therefore, we generate a configuration file that points to the network and route files that we have already created. You can use any editor to generate this configuration file. We are using Notepad and making necessary changes based on the name of our network and routes files. Then we additionally set the step length parameter. This parameter is used by NetSim and SUMO for synchronizing simulations during runtime. Once this is done, you can save it with the extension .sumo.cfg or .sumo.cfg, which are the extensions for the Sumo configuration file. Having done this, we can now load this configuration file in Sumo and run the simulation.